Since the dawn of our time we have looked up, we have stared into the deep dark night. We have seen the countless stars scattered across the blackness like diamonds on velvet. And we have always wondered, what is out there? Are we alone in this vast, silent expanse? This curiosity is part of what makes us human. It is a fire that burns inside us, a drive to know, to understand, to see just a little bit further than those who came before us. We tell stories about the stars. We draw maps of the constellations. We build bigger and bigger tools to peer deeper into the cosmic ocean. It's a journey that began with our own two eyes, and it has led us to the very edge of the universe. So what is this incredible tool that is rewriting our cosmic story? It is called the James Webb Space Telescope, or JWS for short. Think of it as a time machine. It is the most powerful and complex space observatory ever built by humankind, successor to Hubble. But Webb is different. It is designed to see the universe in infrared light. Infrared is invisible to our eyes, but holds secrets of the early cosmos. Its most striking feature is its giant mirror, 18 hexagonal segments, coated in a microscopically thin layer of pure gold. Gold reflects infrared exceptionally well. Mirror over 21 feet wide, much larger than Hubble's. Bigger mirror, equal sign, collects more light, equal sign, sees fainter, more distant objects. Building such a complex instrument was only half the battle. The next great challenge was getting it into space and to its final destination. The James Webb Space Telescope was too large to fit into any rocket in its final form, so engineers designed it to fold up like a piece of cosmic origami. On Christmas Day in 2021, the world watched as it was carried into the sky, the beginning of a long and lonely journey. Its destination was not near Earth, like the Hubble telescope. Webb had to travel much, much farther. It journeyed for a month. As it travelled, the telescope slowly and carefully began to unfold itself. The 5-layer, tennis court-sized sunshield unfurled first. Then the magnificent golden mirror segments moved into place. The world held its breath, and the telescope performed perfectly. The eye was open. For months, the James Webb Telescope has been scanning the deepest, darkest patches of the sky. It has been staring at regions that appear empty to other telescopes. It gathered light for over 100 hours, building an image of unprecedented depth. And in that image, something appeared that should not have been there. It was a galaxy, but not just any galaxy. This one was ancient, seen as it was just 300 million years after the Big Bang. This discovery from a galaxy named Morpheus 1 by the awestruck team defied all expectations. Our models of cosmology said that this was impossible. A galaxy of this size and maturity should take billions of years to form, not a mere few hundred million. So, what did Webb actually see? To understand the discovery, we need to talk about light and colour. Young, hot stars shine with a brilliant blue light. Older, cooler stars have a reddish glow. When we look at a very distant galaxy, the expansion of the universe stretches the light, making it appear redder than it actually is. The light from Morpheus 1 was extremely red-shifted, confirming its incredible distance and age. After accounting for the redshift, the light from this ancient galaxy was still surprisingly red. The light carried chemical signatures indicating heavier elements: carbon, oxygen. Those elements are forged inside stars and released when those stars die. Finding them so early means at least one full generation of stars had already been born, lived, died. Imagine you're baking a cake. You set a timer for an hour. You check after 5 minutes. There's a perfectly baked, decorated, multi-layered cake. That's the feeling in the astronomy community. Morpheus 1 is that impossible cake. Every time we look deeper into space, we also look deeper into ourselves. For centuries, we have wondered if we are special. We have built our philosophies, our religions around the idea that our world, our existence is unique. But as our view of the cosmos expands, our sense of self must also evolve. To learn that the universe was capable of creating complex structures like galaxies so soon after its birth is a humbling thought. It suggests that complexity is not a rare accident, but perhaps a fundamental property of the cosmos. This does not make us less significant. In fact, it might do the opposite. If the conditions for creating galaxies and stars were present so early, then the conditions for creating planets and even life might also be more common than we think. We are made of stardust, as the saying goes. The carbon in our bodies, the oxygen we breathe, it was all forged in the heart of a star that exploded long ago. We could be one of countless points of consciousness, all looking up at the same sky. We are not separate from the universe, we are a part of it. So what happens now? Where do we go from here? The discovery of Morpheus 1 is not an end. It is a spectacular beginning. Scientists around the world are now racing to find more of these impossible galaxies. The James Webb Space Telescope will be their guide. We are at the start of a new era of astronomy. When evidence appears that contradicts our theories, we do not throw it away. We embrace it, because it means we are about to learn something new. The story of the cosmos is still being written. This journey of discovery belongs to all of us. They are for every person who has ever looked up at the night sky and felt a sense of awe. And so the quest continues. The stars are calling, and we must answer.